In question 11, we've got to use forward scanning first up in order to work out the critical path and the minimum project completion time. Then going to use backward scanning to determine all the latest finishing times and then carry out the float times. I've identified the start, the finish, and I've put in the first of the activities. Now please notice here we've got a dummy edge, and whilst that may not take any time, we've got to consider other contributing factors. So it looks like 12 is the only option in this instance. I've got 12 and 18, which is 30, or I've got 27, so I'll go 30 there. Now in this lower branch, I've got a choice of an addition of 13. I've got a choice of an addition of 15, which will give me 27. Moving on, well that can only be 32 or 28, 42 or 28 I should say, so 42, and that makes that 54. So I've identified the critical path which takes in C, G, I and L. I'll just list that down. So the critical path, C, G, I and L, and that will take 54 days. Using backward scanning by default, all the critical path components are going to have the same latest finishing time as appears for the earliest start time, latest finishing time for the previous activity. So I'll fill those in first, and that's by default. The next step, I've just got to do a little bit of subtraction. Here I've got 42 take 9, which is going to give us 33. Down for this lower junction, 27 take 8, which would be 19. So in other words, there's a 2-day delay that could be possible. Working here, I've got a choice for activity H and E. 42 take 16. That's bigger, that's 26, which is bigger than the 15 option, which I've got here. Now I'm just going to quickly turn off the tape and enter those figures on the table. So I've just very quickly entered all the earliest start times. The float times for the activities on the critical path are of course 0. There's no slack there, there's no delay there. To do the others, I'm just quickly reading ahead. For example, D. D can finish as late as 33. E can finish as late as 33 as well. F can finish as late as 19. G is on the critical path. That's got no lateness there. That could be 27. In the instance of H can finish as late as 42. I also finishes as late as 42 days. In the instance of J, that can finish as late as 27. K can finish as late as 42, a popular day number there. And L is on the critical path 54.0. So what I now do, I look at the lengths of the activity and I do a subtraction. So in the instance of 21, take 0, take 15 gives me a float. So I'm kind of working from right to left. 15, take 0, take 6 is 9. 33, take 15, take 2 is going to give me 6. In the next instance, 33, take 30 is going to be 3. 19, take 12, take 5 is going to be 2. 42, take 28, 14. And 27, take 25 is going to be 2. 42, take 30, take 9 is going to be 3. Now that float time, which we've indicated for those activities, are the amount of slack time. So it could be that, say for example, you have a scenario where you can afford to move some workers from activity K to maybe something on the critical path like L, then you might be able to influence or reduce the overall pathway there. In part D, you're asked to consider what would happen if 2 hours was saved in activity G. So it's just probably easy for me to show you the completed result. Now, if we saved 2 days in activity G, that was on the critical path, that reduces the overall completion time to 52. You'll notice, though, that we've now got 2 critical paths there. For the case of E, if we saved 4 hours on activity G, which I made 11, our critical path is now C, F, J, I, and L, which will still be 52 days. So when you're manoeuvring resources and thinking about savings, etc., got to target and target constructively. And project networks are used to analyse scenarios where we might be able to save a bit of time. And of course, time is